Hi students, welcome back to ChemOrgChem. In this JEE Chemistry Insight series, we have been exploring the solution for previous year JEE Chemistry exam papers. If you are new here, don't forget to subscribe and hit the bell icon for notification. Let's see what's today's problem. So this is the question from JEE Advanced 2025. Here you can see that one reaction sequence is given. So here we are asked to find out the amount in gram of S produced in this reaction sequence. So for this, here they given each reaction condition for every steps of in this reaction sequence along with how much yield they get in each step of this reaction. So apart from that, they given atomic mass in AMU units for hydrogen, carbon, oxygen as well as bromine. So let's see how to solve this question step by step. So for solving this question, first we need to find the product structures of P, Q, R, T as well as S. So let's see how to solve this question. So now you can see that substrate X react with sodium triether. So this is the reaction condition for Wurtz-Fittig reaction. So Wurtz-Fittig reaction is one of the chemical coupling reaction that forms new carbon-carbon bond between aryl halide. So now you can see that this is the aryl halide. So when it interact with sodium triether, which kick off sodium bromide along with generation of these carbon radicals. So now this carbon radical combined with another same carbon radical to produce this carbon-carbon coupling product. So this is the symmetrical compound. So this reaction is Wurtz-Fittig reaction. So now this intermediate when it undergo hydrolysis, so here what happened? So now you can see that, so here there are two acetyl groups are present. So when we treat under acid, here hydrolysis takes place to produce this product P. So this is our product B contains two aldehyde functional groups. So in order to cross check our product P, so here you can see that they given molar mass, so which is 210. So now we can cross check either our product structure B is correct or not. So for that here you need to count how many carbon atoms are present in this product B. So here there are 14 carbon atoms and 10 hydrogen atoms and 2 oxygen atoms. So in this question they already given atomic mass of carbon, hydrogen as well as oxygen. So when you work it out, so you will get 210. So therefore the product structure P is correct. So let's moving on. So now our product P which react with sodium hydroxide under heating. So now you closely look our compound structure P, so which contains two aldehyde, especially two non-ionizable aldehyde. So when it react under strong basic condition, which undergo disproportionation reaction, so which means that one of the aldehyde get reduced and another aldehyde get oxidized. So this reaction is Cannizzaro reaction. So as per Cannizzaro reaction, so this aldehyde get oxidized, so we generate this corresponding carboxylate ion. At the same time, this aldehyde get reduced, which produce this corresponding alkoxide ion. So when we treat under acid, so we generate this product structure Q. So this is our product Q. Our product Q contains carboxylic acid as well as one alcohol functional group. So let's moving on. The next step, our product Q react with sodium hydroxide and calcium oxide under heating. So which is a soda lime under heating. So usually here decarboxylation takes place. So now you can see that one carboxylic acid group is present. So therefore, which undergo decarboxylation to produce this product R. So now our product R contains only alcohol functional group. So now this R react with phosphorus dibromide in the presence of diethyl ether. Here diethyl ether acts as a solvent. Under this reaction condition, bromination takes place. So here this hydroxy group kick off. Now instead of this hydroxy group, one bromine atom going to substitute in this carbon. So resulting that generation of this product T. So here SN2 reaction takes place to produce our product T. Now this product T undergo final step of the reaction. So now our product structure T, which contains alkyl bromide, so which react with in next step R. So here you can see that R contains alcohol functional group. So here what happened? The sodium hydride, which readily abstract the proton from this alcohol, which generate their corresponding alkoxide ion. This alkoxide ion now attack this carbon and kick off bromine atom, which generate their respective ether as a final product. So this reaction is Williamson ether synthesis. So this is our product structure. Yes. So now we successfully found that all the product structures of this reaction sequence. So now you can see that. So here you can see that all our product P, Q, R, T as well as S. So here in our question, they are asked to find out the product amount in gram S obtained in this reaction sequence. In order to calculate the amount produced in this reaction sequence, for this we need two important information. So one is molecular weight of S and another one is how much mole is produced in this reaction, especially how much mole of S produced in this reaction. So in this reaction they given X, how much mole they taken S in this reaction sequence. So they taken 16 mole of X in this reaction sequence. So apart from that they given in each step how much percentage of yield produced in every product. So now you can see that the first step of the reaction, which is produced 100% of yield, they taken 60 mole of X. However, here you can see that two molecules combine to produce this product P, even though this is 100% of yield. So therefore we need to divide by 2. So therefore 16 mole divided by 2, which produce 8 mole. So 8 mole of P produced in this reaction, I mean first reaction. So the second step of the reaction, which produce 50% of yield. So now you consider 8 mole is 100%. So when you divide by 2, you will get how much mole of Q produced in this reaction. So which is 4 mole of Q produced in this reaction. So the next step, the R is produced 50% of yield. So just like our previous case, here you just divide by 2 this 4 mole, you will get 2 mole of R produced in this reaction, and T also produced 50% of yield, therefore 2 divided by 2, so which is 1 mole of T is produced in this reaction. And the final step of the reaction, which produce 50% of yield, therefore 1 divided by 2, so which is 0.5 mole, therefore 0.5 mole of S obtained in this reaction. So next we need to calculate the molecular weight of S. So for that they given atomic mass of hydrogen, carbon, oxygen as well as bromine atom. So next we need to calculate how many carbon, hydrogen, oxygen atoms are present in this molecule S. So there are 26 carbon atoms are present. Each carbon atoms get 12, therefore 26 multiplied 12, so which is 312 12. And next, there are 22 hydrogen atoms are present in this molecule. Yes, therefore 22 multiply 1, which is 22. And only one oxygen atom is present. So 1 multiply 16, so which is 16. So when you add these values, you will get 350. So in order to calculate amount in grams S obtained in this reaction, so therefore mass of S obtained equal to moles of S into molar mass of S. So we already found that 0.5 mole obtained in this reaction. So therefore 0.5 multiply 350, so which produce 175. So therefore 175 gram of S obtained in this reaction sequence. That's it for today's problem. I hope this video has helped you to understand this question. If you enjoyed this session, just give it a thumbs up and share it with your friends. And don't forget to subscribe ChemOrgChem for much more content like this. And finally, thanks for watching. Bye bye.